6.2 Systems of Equations with Substitution. We're going to do this algebraically solving systems today, and we still have those three possibilities. All right, so now we're going to be talking about a lot, and then we'll work some problems. Recall that systems of linear equations, remember linear means line, so these are all lines, could have three possibilities. You could have one solution, which is an ordered pair. You could have no solution, or infinitely many solutions, which means all the numbers will work. This will be true also for systems with solving them by substitution. When solving by substitution, you have several steps that you need to go through. And as you do these, they'll become a little bit easier for you to do. The first step is to choose the equation that has a variable. It doesn't matter whether it's x or y, whichever one you want to do, that has a coefficient of 1. Coefficient, remember, is the number in front of the variable, so you only want numbers in front of the variable that are 1 and nothing or nothing. Anything else you don't want to mess with. If you don't have one, you can make one by solving one of your equations for either x or y. Most of these will be probably very simple that you'll be able to do. The second step is solve for that variable. Whichever one you picked, x or y, you solve for that variable. Now, everybody in class may have different answers, but at the very end, they'll have the same solutions. Okay, so when we're working these problems, just be patient, because some person might have chose to solve for x, some person might have chose to solve for y. Just remember, at the end, everyone should get the same solution, so just be patient when we're going through questions and things in class. Number 3, you're going to substitute or replace that equation in for the same variable in the other equation, and you'll see what we're talking about. It sounds kind of weird, but you'll see what we're talking about when we start working these. You're going to solve that equation for a variable. So you'll have something like x is equal to 2 or y is equal to 3, something like that. Then you're going to take that number and you're going to substitute that back into the equation you started with in step 2 and solve that equation. So whichever one you solve for x or y, you plug it in there. It makes it a lot easier, and you'll get your other variable. When you're finished with all that, you will have an x equals and a y equals value, which is your ordered pair solution, which is that intersection. When we were doing graphing, that's your intersection. All right, so then you're going to write your ordered pair. So when we get going on these examples, you'll see what we're talking about. All right, so the first example is x plus 2y equals 4 and 2x plus y equals 5. The first thing you want to do is solve one of these equations. It does not matter, and that's why it's going to be really very varied in class, because someone might pick this one, someone might pick this one. It doesn't matter. At the very end, you'll still get the same answers. All right, so solve one of these for a variable. Solving the top equation, if I picked that one, I would solve for x, because notice that the x does not have any coefficient in front of it other than the assumed 1. So that would be an easy one. You could also have picked the bottom one and solved it for y. It does not matter. Okay, so whichever one you want to do. All right, so if we're doing the top equation for x, this is what it will look like when you finish. You move your 2y over by subtracting. So this ends up being x is equal to negative 2y plus 4. Take that equation, this part right here, and you're going to substitute it in for x in the bottom equation. Okay, so you're going to have to keep straight which one you did. You may want to put, a box around the one you solved. That way you know what you did. Okay, so x is equal to this. So that means x is that. So we're going to take this and plug it in right here. So that becomes 2, and you notice I have a placeholder with the parentheses, and I'm just plugging this right into the placeholders. And I'm going to finish the equation. It's 2 times the quantity of negative 2y plus 4, and the rest of the equation says plus y equals 5, and I add that on right here. You're going to solve for the variable You should not have both x and y in the equation at that point, only one or the other. If you still have x's and y's in there, you've got a mess and you need to go back and fix it. Should only be one variable. In this case, it's just y's. Okay, it could be just x's, but not both. So go back and check your work. All right, from there, you finish solving this equation, which means we're going to have to use the distributive property in order to get this cleaned up. So when I distribute, it's 2 times a negative 2y, which make a negative 4y, 2 times 4, which makes 8. Bring down your plus y and equals 5, and now you're going to combine like terms. I have a 4y and a plain y. That makes a total of negative 3y. Again, if you need to, use your calculator and add and subtract your negative and positive numbers. From here, you're going to subtract 8 from both sides, and when you subtract 8 here and you subtract 8 here, you get a negative 3. So bring down your negative 3y equals negative 3 and divide by negative 3 both sides. That will leave us with just y equals 1. All right, now we've got one of the variables. When we do this and we get this, we're going to take this one back and we're going to plug this in to the equation, that was solved for a variable. You plug it in there, it's really, really easy to find what x is without having to do too much work. So I'm going to plug this back in, so I'm going to write this down here. X is equal to negative 2, and right there where the y was, I'm going to plug in my 1. Okay, so negative 2 times 1 plus 4, right? Because remember, if it's 2x, that means it's multiplication. So it's 2 times 1, or 2 times, in this case with y, negative 2 times 1. That makes a negative 2 plus 4, and then when you put that together, that makes a positive 2. That is x. It's very, very important that you keep track and make sure your variables are right. You will be having an x equals problem and a y equals problem. You need to make sure your variables are so that you can understand what you've got, because then you have to take those numbers right here, these two, and put them in an ordered pair. Sometimes if you solve for y first, people put it in the ordered pair wrong. You need to make sure that you read your ordered pair correctly. This is always x, this is always y, so you look and see which one was x. 2 was x, 1 was my y. So this is my intersection. 2, 1 is the location where it intersects. 2, if I plug them in for x in my original equations, 2 for x and 1 for y will make both of those statements true. Okay, if I was to graph them, this would be my intersection too. All right, so it looks like a lot of steps, but sometimes it can go pretty fast. All right, so this one is 4x plus 5y equals 6, and 2x minus y equals 10. We're going to solve one for a variable. The bottom equation on this particular one would be way easier than the other one. So sometimes it's very apparent which way you should go, and other times you have a lot of choices. I would definitely do the bottom one, and I would solve it for y. So I'm going to take this down here, and I'm going to move the negative 2x, the 2x over by subtracting it. And as you can see, I've already put that down here. I moved it over by subtracting, and then I brought my 10 down. Now I just have to get rid of my negative 1 in front of the y. So I divided everything by negative 1, which left me with 2x minus 10. This is what I'm going to substitute in. Let me make a box around the original so you'll see. This is what I moved around. So I'm going to take this equation and I'm going to plug it into the other equation, this one up here. Okay, so I'm going to write 4x plus 5, and where that y is, I'm going to put a placeholder with my parentheses, and I'm going to plug this in right there, because that's what y is, and then bring down the rest of my equation, which is equal 6. All right, so I have to distribute again. So it's 4x plus, and then 5 times 2x is 10x. 5 times a negative 10 is negative 50 equals 6. Combine your like terms. 4x and 10x make 14x. minus 50 equals 6. I'm going to be adding 50 to both sides, so that'll be 56, and then dividing by 14, which makes x to be 4. You want to take that x and put it back into the equation that was solved for a variable, which in this case it was solved for y. So I'm going to plug it in this equation. It makes it easier to find the other variable. So I'm going to put 2, x is now 4, minus 10. Okay? So that's going to be 2 times 4, which is 8. 8 minus 10 is negative 2. Okay? So now, make sure you put them in the right order. My x is 4, and my y is negative 2. So my ordered pair is 4, negative 2. So that is the location where those lines will cross. Those are the only numbers in the combination of those two numbers that will make both of these original statements true. I could plug in the 4 for x, and then the 2 for the negative 2 for the y, and add them up, and it will become 6. Same with this line. I could put a 4 in for the x and a negative 2 in for the y, and finish that work up, and it will make that 10. Those are the only two numbers combinations that will work. All right, so remember, you can have 3 possibilities though. You can have one solution, which we just showed you, okay, and then you can have no solution or infinitely many solutions. And so far we've only talked about the one solution situation in our examples, but there are other special cases that could happen. So if you can remember back when we were solving equations, we had some weird answer things before. So we've talked about this before. Sometimes when you're using the substitution method, both variables will disappear completely, and they'll leave only numbers on either side of the equal sign. We've had that before. It was a little confusing. I think you probably would be better off with this now since you've already been exposed to that. Just as we had before when we were solving those equations, if it is a true statement, like 2 equals 2, 10 equals 10, negative 4 equals negative 4, if it's a true statement, it means there are infinitely many solutions. That means any x and any y will work. It does not matter, they all work. All right? If the statement was false, that means like negative 2 equals 6, 4 equals 0, things like that. It was not true. That means there are no solutions. That means they will never, never, never cross those lines. They're parallel. There were no numbers that worked, okay? This will happen with substitution also. So I gave you a couple examples of a no solution. This is a no solution, and this is going to be an infinitely many, and you'll see why. When I solve one of them for a variable, I'm going to solve this one for, I can solve this one for y by dividing everything by 2. Y'all are good at that, so let's do that one. So this we're going to end up being y is equal to x divided by 2 and negative 8 divided by 2. And that becomes 1/2 x minus 4. This is what y is. Okay, so if I substitute that in for y, I would get 2x minus 4, and I'm going to plug in 1/2 x minus 4, and that's going to equal negative 8, right? Got to do some work, got to distribute first. Negative 4 times a half x is going to be, let me bring down a 2x, negative 2x, and negative 4 times a negative 4 make a positive 16 equals negative 8. All right, well, this is 2x, take away 2x, they're just gone. Now my variables are all gone. So now I have a statement that says 16 equals negative 8. Is that true or false? That's definitely false. So this isn't true, so that means it's no solutions. And remember, when we were graphing, no solutions meant it was parallel. Parallel lines, they end up having the same slope. All right, on this one, This one, infinitely many solutions, this is what I'm going to do. I'm going to solve this top one for y. So now I'm going to move the 3x over by subtracting. So it ends up being negative y equals negative 3x plus 2. And then when I divide everything by negative 1, that ends up becoming y is equal to 3x minus 2. Okay? Then I'm going to take that and plug it in right here for y. So I'm going to rewrite this problem. It's going to be 12x minus 4, plugging in 3x minus 2 equals 8. And then I'm going to distribute. And then I'm going to end up with 12x minus 12x. Negative 4 times a negative 2 is a positive 8 equals 8. Of course, the 12x and the negative 12x cancels, and then you end up with a statement that says 8 equals 8. Does 8 equal 8? Yes, this is a true statement, which means you have infinitely many solutions. Okay? So a true statement will mean infinitely many. A false statement will be no solution. Okay? And you won't have as many of those, but you do need to make sure that you're aware of them because you will have some. And just know that the no solutions are the parallel lines, and the infinitely many ones, if you were graphing it, was the same exact line. Remember, it was the same line that laid on top of the other. Let me draw another one. They were the very same line. Okay, laid on top of each other. This one was parallel lines, and this one was the same line. Okay, so just know that that's the way the graphs would be if you graphed them. This would be what it would look like if you did the substitution method. A false statement and a true statement. And of course, if they intersect, then you'll have an order pair answer. Okay, so we will be practicing this in class a lot, and come see me if you have any problems. See you in class.